Let me give you another illustration of this, an economic illustration. Suppose you have output is given by this Cobb-Douglas production function, A times K to the A times L to the B. And we're interested in studying economic growth. Economic growth is just the growth rate of output. Okay. So, can you find a relationship between the growth rate of output, the growth rate in capital, and the growth rate in labor? In this expression, Q, K, and L are the variables. Little a and b are parameters, and big A is a parameter. Okay. So given this Cobb-Douglas production function, what's the relationship between the growth rate in output, the growth rate in capital, the growth rate in labor? Well, does anyone want to suggest how we might begin? Yes, Jay. Yeah, it would be just a constant. Yeah, but your suggestion is a good one, Jay. Since the growth rates are the derivatives of the logarithms of the variables, it might make sense to take the log of both sides. If you take the natural log of both sides, we get log Q equals log A plus log K raised to the A power plus log L raised to the B power. And we can further simplify this by writing log A plus little a times the logarithm of K. Bring that little a down. That's rule number 3. Bring this little b down. B times log L. And then what do you do, Jay? Next, if we're interested in getting the growth rates, yeah, just take the derivative of both sides with respect to time. And then we get a d log Q dt. And this, you're right, Jay, this is just a constant. Capital A is just a parameter. So log A is just a constant. So its derivative is 0. But then you get little a times the derivative of log K with respect to time. We're assuming K is a function of time here. Plus B times d log L dt. And there you have it. This, by definition, is the growth rate in output. So the growth rate in output is just little a times the growth rate in capital plus little b times the growth rate of labor. Okay. The growth rate in output is just that parameter a times the growth in capital plus b times the growth rate in labor. So this is kind of an approach that Robert Solow used in his study of economic growth in the U.S. He assumed, well, let's assume a Cobb-Douglas production function for aggregate output. What's the relationship between what explains this growth rate in output? Well, based on this simple model, the growth rate in output is just going to be a function of the growth rate in capital and the growth rate in labor. And you have to multiply the growth rate in capital by this estimated parameter A. You multiply the growth rate in labor times this parameter B, and out pops your growth rate in output.